All right, we are getting started today back on the binary viewing research project. If you didn't catch the last few streams, I worked on the bin dash jam, and then I decided last week that I would make that my long-term project. And I spent one stream sort of doing some of the initial project setup, converting the jam into a long-term project. And I've done more of that work off stream. Now, moving forward, I think I'm going to continue to do the development work, the main stuff like setting up all the UI, setting up refining the plugin system, building out the main UI features that are gonna help with the sit in the core of that tool. All of that is going to happen mostly off stream moving forward because it's mostly a development project at this point. There are some research questions, and I might take those to the stream, but there's a difference between the way I program when I'm streaming, which is that I'm doing sort of the research side of things. I show how I come up with an unknown or a topic that I'd like to learn, and I dig in. And that's what I like to do on the stream because that's a process that's always slow, it's mental, and so there's not a lot of getting into a deep concentration and getting 10 things done in a day kind of work to do when you're experimenting and backtracking and trying and carefully sort of stepping out and exploring. That's the research side. Now that I have a development project going on, that's just going to need me to get into a deep concentration and get a lot done, and I can't do that as easily on stream. So I'm going to start getting strategic about what work I do here and what work I do off stream. But at least for today, I'm going to keep working on the project here on stream, but I'm going to shift gears from doing coding to research on the project to now that I know what I'm going to work on for a while, maybe for the rest of this year, October, November, December, at the very least, possibly more like 6 months, we'll see. But whatever the time span and scope of this bin dash project is going to end up being in terms of the development, there's still some research to do, and that's what I'm going to be getting to today. Before I do, as a reminder, because I've got it up here on the first screen, mrforth.com/membership. If you go there, you can become a supporter or a member. You get access to cool perks, and you help to keep all of these projects going. And if you didn't know, the bin dash project itself is now available. If you type in, let's see, what's a good way to find it? itch.io bin dash. Yeah. Type in itch.io bin dash, you'll find my bin dash project, and you'll find the jam version of the project sitting here. It runs on Windows. It can analyze executable files, DLL files, and object files from the Windows operating system toolchain. So yeah, you can go check that out if you like. It's not fully done. It's not everything I want it to be, but it's what I had for the jam. It's out. It's free. You can check it out. But with that, let's get on to what we're going to do today, which is over the course of this project, I've collected a bunch of recommendations for related projects, things which view, while we're at it, we've already been looking at ImHex, which is another example of one of these. And there's this thing, which someone recommended, and this thing, which is similar to the previous tab that someone pointed me to. So there's a bunch of cool stuff in the space of there's a bunch of cool stuff in the space of binary visualization that I don't know anything about that I want to learn about today. And I might spend several streams doing this kind of work because you'll notice this one here, in addition to being a hex viewer binary analysis tool, it is also a reference list to a bunch of other similar things, including a pointer over to ImHex, which I pulled up. Now, we've been using ImHex, so why don't we start there? So with ImHex, I can open a file, and if it finds a compatible pattern, it will recommend it. And then the pattern is used to create this coloring. So I don't know everything about this system yet, but I can note a few things that I've just felt about it as I've been working with it. So it paints these ranges, and I'm a little unclear on the relationships between these ranges. Like when I highlight right here, this is MZ, and it's highlighting, so it's tool tipping the part where my mouse is directly, but it's, in addition to giving me the tooltip for it, it's um, highlighting a bigger section. And you can see like here it's highlighting all of it, then it's highlighting just that part. If I go here, it highlights all of that plus the cough pointer, but if I highlight here, it doesn't. It gives like subparts. So I'm a little unsure what the rules are, what the highlighting ranges mean. And so that's a UI feature that I'm not happy with. I wouldn't want to recreate that, because if I don't know what it means, then even if it means something reasonable, it's just not obvious. And so there's something wrong with how it's trying to communicate to me. It's also just kind of faint, and there's like information on top of information here. So like the tooltip is covering up the highlighted range a little bit, and that makes it weird. So like, where is the cutoff point? It's a question I'm trying to ask. And I have to move my mouse around a lot to kind of, okay, there, I think, and then, okay, yeah, boom, boom. Then we get this array of things. So its way of marking up the data the raw data into a data structure doesn't give me a whole lot of structure perspective. So let's start by seeing, okay, hold on. There's another thing it does, which it gives me this tree thing. And so when I click on one of these, it shows me the section and then there's the DOS header part and the DOS stub part. So here it's boxing, right? It's using boxing. That's an interesting thought. Maybe there's a color scheme difference. Man, I don't know how I would go changing the theme. Seems like this right here would have it. But there's no like import a theme button, is there? Dark, there we go. So one recommendation I've had is to get a little more serious about the color palette stuff. So like this here is not much better to me. Like I can clearly see the, you know, if you like dark theme, then this is better than the previous one. But like still, there's this problem with these color wheel things that I always feel. Here's classic. Here's dark. I don't like dark. There's light. Native, classic. Okay. Maybe this one's a little better. I don't know. Honestly, not a fan of any of those. Maybe I just got used to running in native theme, which is the light theme. There's this problem though of like it's just kind of picking colors out of a color wheel. Maybe these are even random. I think if I were to reevaluate, it doesn't always give the same colors. Looks like it's doing the same colors right now. So maybe it's using the same seed or something. But let me think. Brown, pink. Here's pink again. Yeah, I'm not sure. It's The point is though that like you could, if you wanted, design a color palette with the right structure to aesthetically do this stuff. So like, here we go. When I select this, it gives me this whole box. Okay? Now this whole box is made up of two sub boxes. Boom and boom. And like, what if this whole box was just one color and this whole box was one color, right? Like, I'm not sure what the exact rule would be, but what if this was one color with variants of the color so that you're not expected to be able to necessarily tell them all apart perfectly, precisely, but that they are colored together in a way that is not so like rainbow jarring insanity as this. Because it looks like what's happening here is it's assigning a color to the smallest field possible of every single like field in the pattern, right? It does not give the larger groups any kind of unifying color. It just goes leaf color, leaf color, leaf color, leaf color, leaf color, all the way through. It can box any of these ranges, but you can see here that the ranges are parsed out in a perfectly hierarchical fashion as well. Now, something I've had trouble with in mine is that our data actually contains other things. So if I box the R data, you can see, so its trick is it's just not assigning a color to our data. I think that might be the main thing. Okay, something else it's doing is whenever I click on one over here, it's jumping me to the relevant line in the pattern file. So I want to learn a little bit about these pattern files. Struct PE header starts with a DOS header. So right here it says there's a PE header expected at 0. Okay. So it's looking for that byte, and then it finds the DOS message offset from that. The DOS stub is this part, okay. Okay, so DOS header. Spec name, eMagic. Why? So here they're just defining struct and driving the layout from that, which makes sense. It's a common pattern. Weird. That matches this. That probably is relevant. So the PHIA header comes in, runs the DOS header, which is just a strict struct that gets laid out. Then find OS message. Must scan from the offset that starts after here, that's the $, until it finds BA, which is this. And the offset, the DOS message offset is set by doing read unsigned I plus 1, 2. So these 2 bytes. E. E stands for 15. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's not 15. Maybe the E is offset from here? Like it's an offset of 15 from the beginning of the stub. So if you don't have a DOS message offset, we're going to do one thing. Otherwise, you're going to do the DOS stub. The DOS stub says, while the current address is less than address of this plus DOS message offset. So the address of the DOS stub is right here, and as long as our $sign is less than that. Okay, so it's basically saying make this thing however long it takes to scan to the end of this. Why not just DOS message offset, I wonder? Using a while loop inside of the square bracket's a little unusual for me. Then we scan until we find stub data. So that's this all the way to there. Then we find one of those bytes. And then while the previous thing we've consumed was not a $sign, we keep consuming. And so then we end up there, and that's the end. Here it looks like it's just saying keep going until you find some zeros, right? While read unsigned 4. So it's reading 4 bytes and putting that into the condition of a while. So if it reads 4 bytes that are 0, it knows it's found the end of the stub, it sounds like, as a fallback. It's weird, interesting. Okay. So a lot of this is about how the pattern language is scripted out to generate these over here. What else is there about this that I should know, that I should get inspiration from? Hello, Terius. Today I am investigating projects similar to my bin dash project to see what type of ideas exist. Cool. Nothing huge. I've just been playing with Imhex so far, but I think I'm pretty satisfied with my understanding of what Imhex is doing. Oh, that's interesting. I don't know if I've seen any uses of this markup before. Anyway, let me actually try something here. Yeah, Imhex provides a bunch of patterns built in. I don't know where the list of those is necessarily. It's a lot of stuff in the PNG. I'm curious about that. Well, anyway, um, that's ImHacks. I think one of the main things that I feel with ImHacks that I don't love is just the visualization itself is not that rich. There might be things I'm missing, but no matter how much I explore, I still just find the coloring of the leaves or whatever the rule is for deciding how to color things kind of an underwhelming thing. The ability to just do that and then box a section when I grab it from the tree underneath, that doesn't feel like enough to me. Um, let's see about this one. So the question is, can I figure out how to set this up? So by the way, we're looking now at FQ, which is a project you can find on GitHub at /waiter/FQ. And there's also this video about it that I haven't watched before. This is all usage. Please don't tell me that you didn't start your usage with a build. Okay. Where is right, so that's usage. What is scoop? I really don't want to do that. You need me to install another program to install this program? Um, all right. We're just biting bullets today. Going against my better judgment and giving this thing a shot. You should see if winget is an option, should be installed by default. I don't know what that means. What do you mean see if winget is an option? And how do I see if it's installed? Over here, the instructions it gave was just use scoop. No more explanation than that. It's written in Go. I don't really want to build from source. You know what? That sounds better. Let's go to the releases page and just download a binary. Thanks for pointing that out. Let's check this out. Okay, there's FQ. So I'm going to take the full path that I have to FQ. I'm going to go drop it in my binary real quick. Create a new text. We're going to do fq.bat. So if I did that right, I should be able to just go like this. Yeah. There we go. Victor, AMD 64 is the same thing as x64. Okay. So, I should be able to do something like go into the build folder. And if it worked, presumably I could do something like this. fq.h for the format list. I don't see a format list. I don't see fq.h giving me any kind of list of formats. Okay, well, if I can't, how did, someone in chat said that they got the list of formats. Yeah, Patrick, you said you got the, oh, it's -h formats, is that what I have to do? Okay, here are supported formats. PECOF doesn't make the list. But, maybe one of these will. I don't have any ELF files sitting around. I don't have any FLAC. I could probably find a GIF. Probably find a gzip. I don't want to see HTML. I guess I'm curious what HTML would actually be about. JPEG, I probably have one of those. So it's got the Lua, or it's got the Mac version 2, it's got MIDI files. MP4s I definitely have. We go try out an PNG again. Zip. Okay. We can do a zip. Looks like gobbledygook to me. I think these should be escape sequences that are making colors happen, but it's not working. Yeah, I don't see any obvious way I'm going to fix that. Let me try PowerShell, see if this is better for it. Same thing. Um, can't run a Windows program from this command line? Okay. What if I did it this way, though? Jesus. What? Are you serious right now? That's how it works? If I go to the home and I hit delete, 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 it does the scroll thing. That time it did not clear the color to white. I don't know what that's all about. /fq.exe. There we go. Now it'll run. Okay. God damn. Please run that on fq0130 windows amd.zip. Hey, there we go. This gives me very little. I think I'm just done with this one. I'm sorry. I'm not seeing what I can learn here. Okay, there's one other thing I might track down, which is what does the format definition look like in this system? It's a Go file. An array of pointers to groups, I guess. An array of dependencies. Array of pointer to groups. Okay, so this format depends on two other formats. Okay. So the way I would characterize this, from what I'm seeing so far, is they've got this kind of decoder class kind of mindset. There's like a input parameter that represents both the data that needs to be decoded as well as the language, the linguistic concepts that will be used for translating that data into the visualization. So we grab those 4 bytes, called the chunk type. And depending on what chunk type we get, we decode the rest differently. That all makes perfect sense. But what is this? Seek -4 times 8, seek 2, field bool ancillary, seek relative 7, field bool private, seek relative 7. I don't know what this is talking about. -4 times 8. It's -32. 7, 14, 21. 23, 28. I only see 28 there. Yeah, it doesn't mean a lot to me. This is the trick you was trying to figure out. But the main idea, I think, is that this is using a procedural Go like I mean in Go, but it's procedural style, if not sort of OOP style. Um, Decode, which is different from ImHex, which is just using a pattern language, right? In ImHex, you define a struct. Here, you're defining what to do with each field. Okay. Um, yeah, there's a lot of stuff in JQ or FQ that I was just looking at that I didn't really get to explore because there's like CLI syntax and stuff, but I'm just not impressed with the tool's basic visualization, so maybe I'm missing the bigger point, but I'm not really sure like how to. Yeah. All right, enough with this one. Let's take a look at these. I want to save this one for last. Wait, you know what? Before I go, there was something else I wanted to look at here, which is on this project, there was a great prior art list to check out. So we looked at ImHex, we looked at this thing. Let's look at some of these others. Hexfiend. Mac OS only. Okay, can't check that out. Binspector. Okay, this sounds a lot like what I'm doing. Except I'm not going to build a language, probably. BFFT's binary file format template. From there, any given binary file can be tested against a BFT in order to verify the binary format meets the requirements of the binary format, analyze the contents of the binary file, and interpret the raw data within. Inspect particular binary values in a file with proper context and interpretation. Intelligently fuzz the binary at potential weak points that may exist in the file import code and auto-generate files containing these attack vectors. Interesting. You can't just make your build. Okay. Okay. Let's see. Are we talking about boost as in like... Yeah. Alright, so we're not building this from source today. Okay. I'm going to look at the PNG BFFT here. Alright, this is looking a lot like the ImHex idea. Except that instead of just declaring a struct and then putting on some checks along the way with each field, it looks like they are using this idea of adding invariants to the structs, which is interesting. Interesting. Their types are like signed or unsigned, number of bits, big or little endian, and then a name. That's cool. Presumably these are the legal values for these, but there's no names associated with the enum codes. Strange. Also, why would these be big endian? That doesn't make a lot of sense. Is that right? Is PNG using big endian? It does make sense that you would want a support for that in a file format system, though. That's a good catch because some file formats just do have big endian integers in there, so it's good to remember that. Okay, but for the most part, I'm basically seeing another pattern based uh, binary description language. Again, declarative. Okay, more and more of these declarative ones. I gotta be honest with you. I think that the declarative method is probably a smart, like, final choice. That's where you want to end up. But you don't want to get there by sacrificing your ability to really visualize. And I'm worried a lot of these are skipping out on the make a good visualizer part. Like, where is the good visualization? This is supposed to be the good visualization of a thing? What are you showing me? Okay, so you have block diagrams in your visualizations. That's cool. Haven't seen that before. Trying to figure out the right way to explore this is a little tricky, though. Okay, so this is the cough header, is what they mean to say. They name things in a funny way. No, wait, no, this is the beginning of the 32-bit section. Some of this is funky. This is unsigned 4 bytes, little endian, unsigned 2 bytes, little endian. Okay. ID means name. But why is there an image base 32 and an image base 64 inside the same header? That just doesn't seem right. That's not what the spec is. That does not match. Oh well. The data DIRs, where is that? Data DIRs. Oh. Wait. This isn't a visualization of the data. This is a visualization of the data format. There's a difference. Because this isn't telling me the values of any of these things. Huh. So again, it's a declarative format. This one doesn't look like structs. It looks like... I don't even know what I'd call this. Sort of like an alternative, a white space significant XML type of format. Just a pretty clean way to do things, if I'm being honest. But still... YAML. I've never looked at YAML before. It's nice. I don't know what these dashes mean. Maybe setting up some kind of grouping, like it groups all of these together. YAML's a disaster, says Ossoff. What's the problem with YAML? One thing I'm seeing, at least in this YAML file, that I don't like. One thing I'm not liking is that there's no blank lines in this file at all. Parsing it is hard, you say. Interesting. Maybe I'm missing some of the features that make it hard, but it doesn't look like it would be that hard. Fascinating. Like, I feel like I'm just seeing a tree structure. Right? Drainyard says the Norway problem. I haven't heard of that. I'm sure that if someone pointed out to me what the hard part is, I would get it. At first glance, I don't see it. Let me see. What are we talking about? Oh, I see. I see. It's not just strings. Okay, so it's not like Metadesk where it's hands off and every key, there's no keywords. Things have types and they get converted. Oof. Okay, I can see the problem with that. Well, hold on. I'm not quite done with Kaitai yet. I wanna understand how good the visualizations get. That's the part I really care about. Nothing. 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 Yeah, I'm not seeing anything here that impresses me that this has useful visualizations. If I'm missing it, someone knows that one of these tools and be like, here's the cool visualization that you want to see. Um, then let me know. Before I go and download this, show me again. Um, this might be big enough that the best way to learn about it would be to Google it. So this is not hex viewing as much as it's looking at the exchange of packets on a socket, it looks like. So maybe not relevant, but also I'm still not impressed with any of the visualization I'm seeing. Yeah. Okay. Man, I don't think that when I say visualization, I have the same idea as what everyone else has. Okay. look at that. Okay, this is really cool sounding. Directly editing binary files without making them ELF specific or any other object file type specific. It's interesting. Okay, so it's combining the idea of a declarative type description of the data with an editor for the structured version of the data that it pulls out. Okay, this seems cool enough that I want to actually go the next step. Is there any chance that this will run on my computer? Hey, to answer your question, Bin Dash is a little project I did. You can check it out on itch.io to see the jam version. I just spent 1 week on it. Initially, just to help me visualize and see everything inside of a DLL file or an executable file or an object file. And after working on it, I started to get the idea that what I really wanted to do was to take the basic idea here and see how far I could take it with extendability and stuff. It's also kind of something I've been thinking about a lot. We were using Imhex to help with parsing executables for a while. And while it's cool, it got me thinking again about this sort of project that I've been thinking about, which is the ability to visualize files based on a description of them. So like Imhex is one of these declarative structure definition systems that then lets you visualize your hex. This over here, what I made, isn't like that. It was specific to these formats when I got started with it, but I'm working now on researching what kinds of tools like this already exist and how they work so that I can benefit from all the existing research that already exists on this problem, because it's kind of the one I'm thinking about tackling for a while after that jam. The question is, does this there's like no chance. There is no chance that this runs on my computer right now. This is very Linux land, which is unfortunate because I want to see it. It sounds possibly cooler than a lot of the other ones that we've looked at so far. But just put it down for later. So this is just a source file? No. No. Okay. I think that's the rest of the things I want to track down from this. Nice, it's another Giddy. Love it. Okay, so as with all the others, the visualization does not impress me. But what is the Honestly, I have no idea. Maybe this one's the wrong format. Let's look at a format I might recognize. Decode. Nice. All right, so the nice thing about doing this in Lua, I guess, is that they're decoding the fields here. And as they decode, this is a procedural definition of the decode. They're putting it all into a variable to remember for later, as well as marking it up for the visualizer. Okay. All right. Okay, this is cool. I'll keep this around. Okay. All right, we made good progress. I'm going to keep this up. We're going to keep going, but I'm going to just take a quick 5-minute break. So, be back All right, what about this? Cool. This seems a little meh. Okay. So there's this other interesting stuff that someone pointed me to that I want to try to understand now. And it's this thing that's like you put in a binary format and it's literally visualizing it. It's not a hex view. It's not a hex view plus some colors. It's a totally visual thing that it creates. Mm-hmm. Mm-hmm. Hmm. Okay. So this is a .wav file. This is a bitmap. Holy crap. That's so different. That's so different. Hmm. Fascinating. Here's ASCII. That makes a lot of sense. It's a bunch of letter pairs, so all the letters, capital and lowercase, are hanging out over here. In whatever pairs that happen to show up, and then the punctuation shows up here. Four distinct block structures. Base64 encoded data. Yeah, it makes sense. Machine code. Very regular grid structure for ARM. Oh, man. It's interestingly different to that one. This has less of a uniform grid, which makes sense because x64 is a encoding with a lot of funky like rules. So many of these. What is that? I don't know. Another visualization technique is the Hilbert curve mapping, originally presented by Alucartesi and the Hilbert curve is a continuous fractal space-filling curve used to map a 1D string of data into an alternative dimensional space. This technique displays data in a concise way while preserving the locality of the data. Yeah. This technique is great for presenting data in an easier to understand format. A quick example. File laid out in a linear format, and the same file translated into a Hilbert curve. You can see structures emerge from this mapping. This is another great way to visualize data dynamically. So here's the linear layout. And here's the Hilbert curve layout. So the initial black pixels become a box right here. And the blue pixels at the bottom become these big blue boxes. Interesting. Yeah, like right here I can now see the blue section that presumably is in here somewhere. This pattern is more interesting than this one for sure. That and that are this and this, I assume. You can see, like, what are these white dots? These big white dots were spread out in here somewhere before. So cool. Okay. Cool. So what is that, a bitmap right there? That micro selector is telling it which region of the file to visualize. It is a bitmap. Fascinating. Cool. This is super cool and useful. I wonder if this is similar, if it's a 3-point plot instead of a 2-point plot. We got three bytes map somewhere into this, create your density map in a cube and render it. Is that the idea? Okay. Hmm. Okay. Okay. Neat. Yeah, this is the same thing as what they're doing, except it's in 3D. Now, the problem I would have with that, besides the fact that I don't have like 3D rotation and all that, is I still don't have a way to click on something if it's in 3D like this, right? Whereas I can in 2D. In 3D, when I click, I'm actually shooting a ray through all of these possible points, and so then somehow it's got to figure out what I meant to click on. The visualization is cool, but I don't know if it's a useful. I don't know if this is a useful interface as much as the 2D version. No, this isn't a Hilbert curve. This is an XYZ plot of, um, neighboring bytes. So it's taking an array of bytes that is the raw data of a given input file, and sliding a window of three bytes wide across that entire array, and each spot where that window lands creates a point on this like three-dimensional scatter plot, and then intensity is used to represent the spots where there are lots of points, and so the dimmer areas have fewer points in them. The really bright points are spots where lots of triplets hit, and so we can see like somewhere in there's this little cube in the middle. That is probably ASCII or something like that. This diagonal through here suggests to me that there are spots where X, Y, and Z have the same value. So like grayscale in a bitmap would look like this. There's also a shadow of that diagonal along this line. So maybe this is a bitmap with, a lot of, it could be like red and green, but not a lot of blue or something. Like some amount of grayscale and some amount of shades of blue is in there. But I don't know. It's cool. I think that'll be it for today. So this is the last one I have, and this one I was sent a while back, and the reason I haven't done this one is that to install it, I would think is gonna take quite a lot. It's a big, enterprisey kind of thing with lots of steps installing. When I click Windows here, nothing is happening. So I assume I'd have to do like cloud-based decompiler. You know what I mean? So like, I don't want to have to do all that. I'm just curious to see if I can get some visualizations. But it doesn't look like I will. Yeah, not impressed. So I'm going to keep this around for later. But I think this is a good amount of stuff. You know, this is a good amount of work for today. We did a bit of looking around at all these existing tools. The big things that I saw that I really liked were, I do think that it's probably in the long run good to have a declarative format, but I don't want to start there. That seems like a thing everyone has gone for first, and they all seem to bottom out with just a boring old hex view at the end with colors on it, and you know, like some tables or trees that get popped out. And I want to push the visualization side. I really like the histogram bitmap stuff and the Hilbert curve stuff, so I might try to recreate those. And there was one other thing I really liked that I hadn't seen before. I'm trying to remember what it was now. Oh yeah, the reminder to think about big endian. I just haven't done a format yet that cares about decoding big endian integers, but that will matter. And so thinking about that and being ready to put that in as one of the features is important. Let's do this to wrap up. Um, all right. All right, so ultimately I think that's it for today. With that, if you're enjoying this research and you'd like to see where my bin dash project goes in the future, make sure to pay attention and follow on Twitch. You can also check out my YouTube channels if you haven't seen it before. I have a YouTube channel called Mr. Forth Unscripted, where you can, it's this purple 4 here. And if you go there, you can see the initial project pitch for BinDash, which I'm currently working on, that I've been working on today. So go check that out if you want to get more of an idea of what the BinDash project is going to look like over time. And follow there if you want to catch new things. Make sure to catch my newsletter if you want to catch announcements about this stuff as it's coming out, and become a supporter or member if you would like to keep the project going. I'm counting on people like you. This is how I keep the lab open, is you look at this and you say, hey, I think that what Alan's doing could make my life as a computer professional better, or as a computer enthusiast better. I could support $5 or $15 a month, and there are cool perks that come with that. So it's much appreciated to anyone who does make that decision. And with that, I will sign off for today. Thanks for checking out what I'm doing, and I'll see you all around the internet. As a final note, since I didn't say this for the last hour or so, I'm going to be modifying my Twitch streaming schedule to be 3 days a week, Monday, Wednesday, Friday, instead of all 5 days a week, because I'm going to be going into development mode on BinDash more, so I need more time off stream to just get into concentration mode and get a lot of stuff done. So we'll be moving down to 3 research days a week, or 2 research days and a 4-coder Friday. So keep that in mind as well as I switch to BinDash. We're going to be doing a new streaming schedule. And with that, see y'all around. Bye bye.